Hello, and welcome to my first math instructional video. This is going to be over the first section that we're doing, so section 1.1, which is all about lines. Alright, so the first important thing to know about lines is to know about the slope. So you have either a negative slope, which means your line is going down as it goes from left to right, or you can have a positive slope, which means your line is going up as it goes from left to right, or you can have a zero slope, which means that you're not going up or down. It's a horizontal or constant line. Or if you have an undefined or infinite slope, that gives us a vertical line. So one way to describe the slope is rise over run. So that is the change in y over the change in x. So the slope formula is m equals y2 minus y1 over x2 minus x1. So that formula gives us the slope of a line that goes through any 2 points. Okay, so let's do some examples. So if we want to find the slope of a line going through the point 7, 5 and 12, 10, the first thing I like to do is label my x1, y1, x2, y2, and then I'm just going to plug those into my formula, which we have up here. So m equals, alright, so I like to kind of write down the bare bones of the formula first, okay, and then fill in my numbers. So that's going to be 10 minus 5 over 12 minus 7. And then we just simplify it. So 10 minus 5 would be 5, and 12 minus 7 would also be 5, and 5 over 5 would be equal to 1. So that slope is equal to 1. Alright. Alright, let's do another example here. So again, I'm going to label x1, y1, x2, y2. So m equals, that's going to be 1 minus 6 1 minus 6 over negative 3 minus 5. So 1 minus 6 is negative 5, and negative 3 minus 5 is negative 8. So those negatives are just going to cancel each other out. So the final answer there would just be positive 5 over 8. Alright, so here's another example where we throw in some more negatives. That's always the tricky part. So, but again, starting out the same way, just label x1, y1, x2, y2. So we have m equals negative 9 minus negative 3 over 4 minus negative 8. So here's the reason why I write down the like the green part first, because you have a negative from the formula, but you also have negative numbers, and that's the place where people will make a lot of mistakes, is they will only write down one of the negatives, okay? So you want to make sure you write down both of them. And then when you have minus a negative, you know we're going to change that to plus. So now we're looking at negative 9 plus 3, which is going to give us negative 6. And then on the bottom we have 4 plus 8, which is 12. So that's going to give me, that's going to simplify to negative 1/2. Alright. So the number 4, same type of thing. All right. So x1, y1, x2, y2. And so then we're going to do m equals that's going to be 6 minus -2 over 3 minus 5/3. So minus a negative becomes a plus. So that's 6 plus 2, which is 8. Now here we have a fraction thrown in the mix. So this can be done on a scientific calculator, and maybe I will insert a little video showing you how to do that, but for now I guess I'll just do it by hand. So we're doing 3 over 1 minus 5/3. So we're subtracting fractions, so we have to have a common denominator. So in this case the common denominator would be 3. So then we need to multiply this by 3, which means we also have to multiply this by 3. So that gives me 9/3 minus 5/3. So the denominator will stay the same. So 9 minus 5 is 4, so that's going to be 4/3. So we're looking at 8 over 4/3. Then we have, since we're dividing by a fraction, that means we're going to flip the second fraction and multiply. So this is basically going to be 8 times 3/4. And then 4 goes into 8 2 times. And then 2 times 3 is 6. So my final answer right here would be 6. Alright, so that was about how to find the slope of a line. Now we want to talk about how to actually find the equation of a line. So we're going to use the point slope formula, which is y minus y1 equals m times x minus x1. Alright, and I like to always have my answers to be in the slope-intercept form, which is y equals mx plus b, where m is the slope, as we know, and then b is the y-intercept. With this particular textbook, sometimes they like to have you put the equation in a different form. I think they might call it standard or general form, which is ax plus by equals c. Okay, which I don't really know why they do it, but sometimes they like to have it in that form, so I'll show you that as well. Alright, so if we want to find the equation of a line with the given characteristics, so slope is 4 and it's going through the point of -3, 0. Alright, so we have m is 4, and then the -3, 0, that is the x1 and the y1. Okay, so in the point slope formula, the first y is just going to remain y. We're not going to plug anything in for that. So it's going to be y minus, then we plug in the 0 in place of y1, equals m, which is 4, parentheses, and then again this x is still going to be x, minus x1, which is -3. Okay, so now I'm going to simplify that to get it in slope-intercept form, which is the most useful form in my opinion. So y minus 0 is y, and then minus a negative is of course a plus, so I'm going to leave that as 4 times x plus 3, and then I'm going to distribute the 4. So that's going to be y equals 4x plus 12. Okay, now if, so that is your slope-intercept form. Now, if they do want it to be in the other form, all we need to do is move that 4x over to the other side. Just subtract 4x from both sides. And so that will give me negative 4x plus y equals 12. Okay. Alright, so for number 6, we want to find the equation of a line that has a slope of negative 2 and it's going through the point 3, 1/3. Alright, so we have our slope, and then we have the x1 and the y1. So we're going to do y minus 1/3 equals negative 2 times x minus 3. Alright, so I'm going to distribute the negative 2. So I'm going to have y minus 1/3 equals negative 2x plus 6. Then I just need to add 1/3 to both sides. Alright, so that gives me y equals negative 2x, and then I need to add 6 over 1 plus 1/3. So again, my common denominator would be 3, so multiply this times 3. That gives me 18/3 plus 1/3 equals 19/3. So there's my slope-intercept form. Now, if I want this to be in the other form, I'm going to want to get rid of the fraction, so I would just go ahead and multiply the whole thing times 3. And so that would give me 3y equals negative 6x plus 19. And then I would just move the 6x over to the other side, so I just add 6x to both sides. That would give me 6x plus 3y equals 19. So that's the other form that you could have it in, if that's what they want you to do. Alright, number 7, slope is 2/3, and it's going through 3, negative 2. So we have m, that's our slope, it's 2/3. Then we have x1 and y1. So we're doing y minus negative 2 equals 2/3 times x minus 3. Okay, so minus a negative is a plus, so that gives me y plus 2 equals. And then I'm going to go ahead and distribute the 2/3, so that gives me 2/3 x. And then 2/3 times 3, the 3 is going to just cancel out, so that's just going to make minus 2. Alright, and then I want to get y by itself for the slope-intercept form, so I'm just going to subtract 2 from both sides. So that gives me y equals 2/3 x minus 4. So there's my slope-intercept form. Now again, if I want the other form, I need to get rid of the denominator. So I'm going to multiply the whole thing times 3, which gives me 3y equals 2x minus 12. And then I just need to move the 2x to the other side, so subtract 2x from both sides. So that gives me negative 2x plus 3y equals negative 12. Alright, now on number 8, so again, remember, let's remind ourselves of what the instructions are. We want to find the equation of the line. Okay, so we're trying to find the equation of a line that goes through these 2 points. Okay, so in order to use the point slope formula, we also need to have the slope. So the first thing we have to do is actually use the slope formula to find the slope. So label this as x1, y1, and then x2, y2, and then use the slope formula. So that's going to be m equals And that's going to be 5 minus 8 over 0 minus -1. So 5 minus 8 is -3, and 0 minus a -1 is going to be a +1. So -3 over +1, which is just equal to -3. Okay, now that's only the first step. So I'm just going to put these two little lines to indicate that this is an answer, but it's not the final answer to this question. Alright, so now I use the point slope formula. So it's going to be y minus 8 equals m, which is -3, times x minus x1, which is -1. Okay, so all I'm going to do on my next step is just cancel out those two negatives. So that's going to be y minus 8 equals -3 times x plus 1. Then I'm going to distribute the -3. So I'm going to have y minus 8 equals -3x minus 3. Then I'm just going to add 8 to both sides. So that gives me y equals -3x plus 5. Alright, and if necessary you can put it in the other form, but I don't feel like doing that anymore, so hopefully you get the idea. Alright, so number 9, I want to find the equation of a line that goes through the point 4, 6 with an undefined slope. So if we refer back to the beginning of the notes, we know that an undefined slope means that it's a vertical line. And if it's a vertical line, its equation is just going to be x equals whatever the x value happens to be, which in this case is 4. And that's it. So x equals 4 is the equation of that line. Then if you have a horizontal line, not a horizontal tine, by the way, horizontal line through the point -3, 7. So with a horizontal line, the equation for that is just going to be y equals whatever the y value is, which in this case is 7. Okay, so now we're going to look at actually graphing lines. So before I graph a line, I like to first have it in the slope-intercept form. So on number 11, I do have it already in the slope-intercept form. So let's make sure we can identify the slope and the y-intercept. Okay, so remember we're comparing this with the slope-intercept form, which is y equals mx plus b. So the number that's in front of x, that's the slope. So in this case, that would be 2. And then the number after the x is the y-intercept. So in this case, that would be -5. Alright, so I'm going to first plot the y-intercept. So that means I'm going to go on the y-axis, which is the vertical axis, and put a dot on -5. Alright, now my slope is 2, which is also the same thing as 2 over 1, which tells me that I'm going to go from that point that I just plotted, I'm going to go up 2 and over 1 to get my next point. And then I can just continuously go up 2 over 1, up 2 over 1, up 2 over 1 to get however many points I need to get. Okay, and then I'm just going to connect the dots, and that's my line. Alright, so number 12, the same thing. So in this case, the slope would be -4/3, and the y-intercept would be +1. So I'm going to go and plot my y-intercept at +1, and then since my slope is -4/3, that means I'm going to go down 4 over 3. from the point that I just plotted. So 1, 2, 3, 4, 1, 2, 3. And I don't really have room to do any more points, so 2 points is sufficient. Although if you're doing it by hand, more is always better, but it's good enough. Alright. Now on number 13, this equation is not in slope-intercept form. So the first thing I want to do is put it into slope-intercept form, which means I need to get y by itself. So in order to do that, I'm going to subtract 3x from both sides, and I'm going to add 2 to both sides. So that gives me y equals negative 3x plus 2. So now it's in slope-intercept form. So now I can see that the slope is negative 3, and the y-intercept is 2. So I'm going to go ahead and plot my y-intercept at positive 2, and then since the slope is negative 3, that's the same thing as negative 3 over 1, which means I'm going to go down 3 and over 1. And I can go again down 3 over 1. Okay. And draw the line. Alright, on number 14, again, I am not in slope-intercept form, so that's what I need to do. So first I'm just going to kind of switch it around. I have 2x equals 8y, so I'm just going to rewrite that as 8y equals 2x. And then I need to get y by itself, so I need to divide both sides by 8. So that gives me y equals 1/4 x. So my slope would be 1/4, and my y-intercept is actually going to be 0 since I don't have anything here. It's kind of the same thing as having a plus 0. So go ahead and plot my y-intercept at 0, and then since my slope is 1/4, from there I'm just going to go up 1/4. Alright, now I don't have enough room to go up 1/4 again. However, if I want to still get another point, well, positive 1 over positive 4 is actually the same thing as negative 1 over negative 4. So what I could also do is go down 1 and then backwards 4. So in other words, to the left. So when we go over, we go to the right, but when we go backwards, we go to the left. So I could go down 1 and left 4 to get another point. And again, when you're just doing this on the computer, you know, it really doesn't matter. All you have to have is just any 2 points. But still, this may come in handy for you sometime. Alright, so on number 15, I don't even have a y to get by itself, but I do have an x, so I'll just go ahead and get the x by itself. So to do that, I need to divide both sides by 3. So that gives me x is equal to 3. Alright, so since it's x equals 3, I know that that means that it's actually a vertical line. Alright, so that means that my slope is actually undefined when it's a vertical line. Okay. And so basically what it's going to look like is x equals 3, so I just go to where 3 is on the x-axis, and I just go ahead and draw a vertical line there. And again, when you're doing this on the computer, they're going to require you to plot 2 points. So just pick any 2 points that have an x value of 3 and just plot those. Alright, so as you can see, the y-intercept, there is not one. So there is no y-intercept, which is not the same thing as saying that the y-intercept is 0, because that would mean that it crosses here. but it does not. So we just have to say that there is no y-intercept. All right, and number 16, we want to get y by itself. So we're going to subtract 12 from both sides. And then that's going to give me 3y is equal to negative 12. Then I'm just going to divide both sides by 3. So that's going to give me y equals negative 4. So that is actually a horizontal line. Okay, so it's a horizontal line at negative 4. So if I just go to where y is equal to negative 4, and I just draw a horizontal line, and just, plot any 2 points on there for the computer. All right, so the slope is actually going to be 0. So if we have y equals 4, that's kind of like the same thing as saying y equals 0x minus 4. Okay, so then the y-intercept in this case is actually negative 4. Okay, so what if we actually have the graph that's given and we wanted to figure out what the equation of that line was? Okay, well, the first thing I would do is locate the y-intercept, which is here at negative 1. So I can say that b equals negative 1. Okay, then I want to identify another point on the line, which would be better if this was like a nice perfect line created by a computer, but it wasn't. It was created by me, and I'm not very perfect. So I'm going to go ahead and say that right here is a nice point that we could identify. And then I just want to figure out, okay, well, what do I have to do to get from one point to the next? And we're always going from left to right. So to get from this orange point to get to this pink point, I have to go up 1, 2, 3, and over 1, 2. Up 3, over 2. So that tells me that my slope is going to be equal to 3/2. And once I know those two pieces of information, that's really all I need, and I just plug it into the slope-intercept form. So that's y equals 3/2 x minus 1. And that is the equation. All right, and then on number 18, I've got a vertical line, so I automatically know that the equation for that is just going to be x equals to whatever the x value is, which in this case is negative 1. All right, so now since this is a business math class, let's go ahead and look at some business applications. All right, so number 19, it says that a company that manufactures light bulbs has a fixed cost of $7,000. It costs 12 cents to produce each light bulb. Write the total cost as a function of the number of light bulbs produced, x, and use the function to find the cost of producing 8,500 light bulbs. Okay, so we have a fixed cost of $7,000. So that could include, that's like your overhead. That includes keeping your factory open and maybe your advertising and paying your CEOs and whatnot. Okay, so, and then say for the labor and materials just for each individual bulb is 12 cents. All right, so we're going to write down the cost function, and we'll just call that C of x. So we have 7,000. Okay, so that's right off the bat. Even if we don't produce a single light bulb, we still have a cost of 7,000 just to have, our business operating. Then we're going to add 12 cents for each light bulb we produce, and they've said that x is the number of light bulbs produced, so that's going to be 0.12 times x. So that's my cost function. All right, and now they want to know what is the cost of producing 8,500 light bulbs. So that means that we're going to say x is equal to 8,500. And we're just going to plug that in place of x in the cost function. So basically what we're saying is C of 8,500 equals 7,000 plus 0.12 times 8,500. Okay, and then I would just type that into any old calculator. I'll just get my nice little calculator right here and do it. Okay, so 7,000 plus 0.12 times 8,500. And that gives me $8,020. All right, so equals $8,020 to produce 8,500 light bulbs. Okay, so here is another application. Suppose a cell phone plan costs $40 per month and includes 1,000 minutes. If you go over 1,000 minutes, you will be charged 2 cents per minute that you went over. Write a piecewise defined function for your total bill. Okay, so that just means we have two different situations. Either you went over your minutes or you didn't. Okay, so we have not over and over. Okay, and so we'll give this function a nice name like f of x equals, and since it's a piecewise function, we're going to have two different pieces, so you get one of these fancy brackets. Okay, so if you don't go over your minutes, how much are you going to pay? Well, you're going to just pay $40. Okay, so that is true if x, which let's remember that x equals total minutes used. Okay, so if x is less than or equal to 1,000 minutes. Okay, but if you do go over your minutes, you're still going to pay the $40, plus you're also going to pay the overage charge, which is 2 cents, times the number of extra minutes. So the number of extra minutes would be x minus 1,000. Okay, and that's the piece of the function that would be used if x was greater than 1,000. All right, so that would be the function right there. And that was all that they asked us to do on that question. All right, so number 21, suppose a new house is worth $110,000 and appreciates $3,200 per year. So the value increases, which is usually what happens with a house. So write a function for the value of the house x years after it's built. Use this function to find the value of the house after 12 years. Okay, so I'll just call this function v of x for value. So it starts out at $110,000 and then plus $3,200 for every year after it's built. So that's going to be plus 3,200x. All right, so that's my function. And then if I want to know its value after 12 years, I'm just going to plug in 12 for x. So we're going to say x equals 12. So basically v of 12 equals 110,000 plus 3,200 times 12. All right, and again, I'll just go to my nice little calculator and type that in. And that gives me $148,400. Oops. All right, number 22 says a lawn care company has fixed monthly costs of $925. Each time they mow a lawn, it costs them $30 in labor, transportation, and materials. The company then charges the customer $50 for each time they have their lawn mowed. Write functions for the company's monthly revenue, cost, and profit as a function of the number of jobs done per month. So we're going to have x equals number of jobs done per month. Okay, so first we will start off with the it doesn't really matter, but let's start off with the revenue function. So that'll be called R of X. So revenue means the amount of money that they actually take in. So since they're charging the customer $50 per lawn, they're actually taking in 50x. Okay, so 50 multiplied times the number of jobs they actually do. So then we're going to have the cost function. So that'll be called C of X. All right, so they've got that $925 fixed cost. So, you know, who knows, that maybe covers advertising or insurance or whatever. So 925, okay, so they have to pay that whether they mow any lawns or at all or not. Plus the $30 that it actually costs them to mow each individual lawn, so plus 30x. All right, and now your profit is always going to be equal to your revenue minus your cost. So how much you took in minus how much you spent. So P of X equals 50x minus, and then let's put this in parentheses so that we make sure that we know that we're subtracting that whole thing. 925 plus 30x. All right, and then let's go ahead and simplify that by distributing the negative throughout the parentheses. So that gives me P of X equals 50x minus 925 minus 30x. And then we're just going to combine like terms. 50x minus 30x is 20x. So P of X equals 20x minus 925. Alrighty, so that concludes this video, and I hope you liked it, and let me know if you have any questions. Thanks. Bye-bye.